Hello everyone, this is Columbia University E6893. Our project is about Manhattan subway analysis and visualization. We are group 16. Today, let me introduce our project. First is our problem definition. Our goal is to analyze this New York City subway data in a stream way and find out general patterns in the load of subways and the flow of people. We can use it in many cases, like subway inter-ridership, virus 7 days a week, throughput for different times of the week, and enter-exist throughput of each station. Here is our system design. In our backend, we use dataset from empty raw data. We use the turnstile data, and we also create a station coordinate. We merge them together and filter, aggregate, and sort. We use Spark and Flask to do this in backend. In the front end, we use Google Map and JavaScript to write. And between backend and front end, we use RESTful API and HTTP to connect them. So here is our demo. Let me show it. Pie chart. So here we can run the app, and then we can get two fields like this JSON field and the top 10 station JSON field. Here we can get some information, and then the backend will send this information to the front end. Then we run this. We can get our website here. Like they consist of 3 parts. First part is our daily throughput for each day of the week and the throughput at different times. It's a pie chart and a line chart. Here we can see it's from Monday to Sunday, and we also get the entries number, exist number, and the total number. Then is our second part, top traffic station at current time. So here we can see the time here, and we can get the busiest station at each time. Then with sidebar we can get a different time, the busiest station. The third part is our map. We can zoom in or zoom out, use our mouse wheel. Here you can see there are 2 circles here. The blue one, we use blue one to represent the enter number, and the red one to represent the exist number. Also you can slide bar, and we will see the circle changed with the time change. So here we also designed the start streaming button. We can click here, and we can find the time automatically increase, and our map will change with the time increase. So here is our demo. Okay, this is our data set. It's from empty raw data. You can see there's a screenshot here. It's very unreadable, and we have no idea what it talk about. So we just put it here, and we can find some information about it. It contains of control area, remote station, line name, division, date, time, entrance number, and exit number. We can just do this and get the enter number or exist number. So here are some problems. We need the latitude and the longitude to draw the map, and there are also duplicate names about the station. Here is an example. They both name the same station, but they are totally different local, totally different in location. So here is our solution. We created a CSV field, like here. Use station line name division to match the station in origin data with the CSV field to obtain accurate latitude and longitude. our backend and the technique detail. First is about pre-processing. First we load in the turnstile data and the station coordinates data. Then we merge in the data set to combine the station coordinates and the ball information with turnstile data. The third step is to filter out the station not located in Manhattan. Then we filter out the irrelevant data. So here are two screenshots about this pre-processing. Then is our data processing. First we get the number of entries and exist to turnstile at each station for each time and for each date and time. Aggregating the data by station, date, and time, calculating the total number of people. You can see here, we calculated the total number and enter number or exist number. Secondly, we defined the top 10 busy stations with the highest number of people on each date and time. So here is rank 1 to rank 10. Third, we calculated the total number of people in all stations for each date or time. We calculate the traffic stat for each day in a week, the traffic statics for different intervals in a week. Like here, there are two pictures here. We use Flux API defines various endpoints for use to query the processed data, such as in retrieving data by date and time, or fetching the top 10 busy station. In our backend, we have some problems like the turnstile data is recorded every 4 hours. Ideally, the recording time should have consist such as 1, 4, 8, 12 o'clock. However, we encountered inconsistently in the dataset where some records had data record in irregular intervals such as 1 o'clock to 5 o'clock. So we solved this by grouping the data into 4-hour intervals. And for each group, we standardize the time clock by setting it to the end time of the interval. So here we use two optimization algorithms. First is operator recording, and then is redundance elimination. About our front end, we have three components. We have shown in the previous demo, including pie charts and line charts, top 10 list, and the dynamic map. Each of them function independently for best readability, meaning each of them would fetch, process, and present data independently. For the dynamic map, we use Google Map API to achieve it. So here is our simple response for data. And the P1 is formed by station, add line name, and division. This greatly the uniqueness of the station because the original MTA dataset used these three fields to identify the station. So here is our simple response for top 10 station. There are event listeners on both the stream button and the sliders. When the user interact with these DOMs, the get throughput and the update circle functions will be called to update the circle on the map. Also, the get top 10 and the update table function will be called to update the top 10 list on the site. So here we also face some problem in our front end. We found that we need a unique ID to order. So how to solve this problem? We decided to use station, line name, and division as the unique ID to identify each station and the corresponding circle. Also, there's some problem in the midnight. We found that the circle will be very small, and however, the raw data will be giant when there is spark. So it's better user experience when we use linear. So we just use log to adjust the circles speak and it very visible and reasonable reading even when there is a spark. So that's all of our project. Thank you for your listening.